Yes.
That's then it must, I mean, अगर उसके बाद भी कुछ mistake होंगे, then all of those mistakes will be solved only in the examination. Preparation में आपका overall मतलब ठीक increase हो रहा है, इसी तरह से वो increase करते रहिएगा. Okay. I hope now you know where you have to focus and how you have to focus also. Okay.
Yes, sir. Sir, can you check the 16th question?
16th question. अच्छा, fine. Just both of these are correct, right? I mean, at least these are true statements. Yes or no?
Yes.
But is that the reason? No, that is not the reason. So the answer will be both A and R are true, but R is not the correct explanation. Correct explanation is going to be lanthanoid contraction. Okay. Because अगर एक group में अगर आप if you have atoms or elements in the same group, as you go down the group, the atomic size should increase, but it is not increasing. They're almost the same because of lanthanoid contraction. Okay, so lanthanoid contraction is the correct reason, but the statements are true. Zirconium and hafnium, they both belong to the same group, and also they have similar atomic radii. Anything else?
No, sir.
Oh, I think this was like DNF block heavy type of question paper. No. You have other chapters also. I hope organic was fine.
Yes, sir.
Organic was fine. Okay. A first order reaction is completed 50% completed in 40 minutes and 50% completed in 20 minutes. Calculate the energy of activation. Achha. This will be from your temperature dependence जो हमने lecture recording भेजा था आप लोगों को. And then previous calculate the rate. Oh, this is easy. I think you should have done this SO2Cl21. This is better. Ideal solution will be defined as this states Rawls law for solution. Okay, I mean this is easy. What type of azeotropic will be found in sodium acid? Isme I hope you remember these things because we did acetone and chloroform, right? You remember that acetone and chloroform?
Yes, sir.
याद था आपको? ठीक है, चलिए ठीक है. But yeah, like the question will not be anything different, like from either it will be from notes or direct from NCERT questions. चलिए fine. All of you can see the screen, right?
Yes. Yes.
Yes, sir. No. Okay.
No.
Fine. Like this chapter, coordination compounds. Before coordination compounds, do you know what is double salt? Guys, Do you have idea? Have you heard of this word double salt?
Yes, sir.
Yes. Can any one of you remember anything from double salt? Can you give me an example?
I think it contains 2 or more ions.
That is correct. Okay. Now, coordination compounds and the double salts, they kind of have similar, I can say similar formula. Okay. And here also you may seem that these are what? These are like double salts only. But the major difference in double salt and the coordination compound is that when you are going to mix coordination compound in water, they are not going to ionize. But when you are going to mix double salt, these are going to ionize. Okay, so this is the major difference between double salt and coordination compounds. First of all, write some definitions. There are some terms that we need to know whenever we start some type of new chapter. Okay, please write. Coordination compounds have central metal atom surrounded by ions or molecule beyond their normal valency. Okay. These are also called complex compounds. Right, next. These are formed from combination of two or more simple stable compounds and retain their identity and retain their identity in solid as well as in dissolved state. Done. Can I move on?
Yes, sir.
Okay. See, for example, when you mix NiCl2 with ammonia, now NiCl2 is green in color. Okay. This is green in color. And ammonia is colorless. Okay, aqueous ammonia. I mean not aqueous ammonia, rather liquid ammonia. Okay, aqueous का मतलब भी हो जाएगा कि पानी में है. No, ammonia in liquid form. Generally, ammonia you will get in gaseous form, but ammonia in liquid form. If you are going to mix both of these things, what happens? You are going to get a product. Okay. When you are going to mix both of these things, you get something in purple color. Okay. There is some product which is in purple color. Now, obviously, see, whenever I say reactions happen, please remember that when we have NiCl2, then in that particular solution, there will be not written NiCl2. ठीक है, वो पानी में ऐसे NiCl2 करके नहीं लिखा रहेगा. How do we identify whether it is NiCl2? So उसमें characteristic होता है. One of the characteristics is that it is green in color. Now, as we are mixing NH3 in it, then we get something which is purple in color. Then obviously NiCl2 is not now. We have got some new compound, and we have got some new compound, and that new compound is purple in color. Okay, that new compound is purple in color. And when you are going to evaporate the solution, that means you are going to evaporate the remaining NH3 and remaining water molecule if you have any, then you get some crystals, and those crystals are also purple in color. And when the formula for that structure was found that it has nickel, 6 NH3 molecules, and 2 chlorines, Cl2. So this was the structure which was formed. Please write this down, then we'll define each and everything here. And this is a coordination or complex compound. Okay, also when is dissolved in water, it dissociates as following. यहाँ पे आपको दिख रहा होगा that nickel, that metal is not getting dissociated. You have nickel and NH3 whole 6 which are in one coordination, and they are not splitting, they are not dissociating. Okay, but I will give you some example of double salt. In double salt, each and every species get dissociated. For example, I don't know if you remember one double salt which is known as more salt, right? In more salt, what is the formula? We have FeSO4 dot NH4 whole twice SO4, and then we have 6 H2O molecules. When I'm going to dissolve that in water, I will get Fe2 plus, I will get SO4 2 negative, I will get NH4 plus, and I will get water molecules. So each and every species get dissociated in double salt, but that does not happen in coordination compound. Let me know when you're done.
Done, sir.
Done? Please write. What are double salts? These are addition or molecular compounds. These are addition or molecular compounds. Addition or molecular compounds formed by two saturated compounds but lose their identity when dissolved in water. For example, FeSO4 dot NH4 whole twice SO4 dot 6H2O. When you're going to add water to it, I mean, this is water of crystallization. Okay, this is not water in the sense of liquid water. It is formed, it is present there just to have liquid state. You will get here Fe2 plus NH4 positive plus SO4 2 negative. Okay, and water will be there. Okay, so as you can see, each and every ion is getting dissociated and it is losing its identity. But and also like the color and all, it also changes when you add water. But if you have purple colored coordination compound, and if you add water, it will be still purple and it's not going to lose any of its identity. After this, please write this down. Please raise your hand once you're done. Okay. Rifat, just waiting for you. Let me know once you're done. Okay. Okay, you can lower your hand. And now we are going to understand some explanation of these coordination compounds. Okay, some explanation of these coordination compounds. First of all, I'm going to give you some experimental results. Okay, we are going to look at some experimental results that was given by Alfred Werner. Okay, that was given by Alfred Werner, and it is known as the Werner's theory of coordination compound. Now, the first thing Werner did was he prepared many coordination compounds. Okay, he had many coordination compounds. Okay, now he had, and also he did most of its coordination chemistry in the metal of cobalt. Okay, so he did cobalt chemistry mainly in coordination compounds. So, what are the coordination compounds that he made? Let's see. First, he did a reaction. He took cobalt chloride, that is COCl3. Okay, and he did different moles of ammonia. So if you take 1 mole of ammonia, then nothing happened. 2 moles of ammonia, then nothing happened. And 3 moles of ammonia, nothing. Then he took 4 moles of ammonia. When he took 4 moles of ammonia, what he saw that he got a compound which was green in color. Okay, which was green in color. Now, then whenever you do an experiment now, उसको क्या करना रहता है? Reproduce करना रहता है. That means you have to do that experiment once again, just to show that this was not by some mistake. We had some kind of theory with it, and we can produce COCl3 plus 4NH3. It is going to give you some green color compound, and that green color is due to some compound which is formed not due to some impurity that is present, not because some other metal was already present in the beaker, and when he added these two things, it got a green color. So when he did few more experiments, he got the green, but sometimes he also got with 4NH3. He also got violet color molecule. So these two colored molecules, green and violet, was given. When he had the formula of this compound, he said that it would be, for both of these, it will be what? COCl3 dot 4NH3. Okay, because if he took, let's suppose 1 mole of COCl3, then 4 moles of NH3. Okay, then he is increased the number of NH3, the volume of NH3. Wait a second, 4 NH3. From 4 he went to 5. For each moles of cobalt chloride, he added 5 moles of NH3. When he added 5 moles of NH3, he got the color that is purple. That means he is mixing the same, he is mixing what? He is mixing the same reactant species, but in different ratio, and he is getting different molecules. Then he added again COCl3 and 6 ammonia molecules. With this, he got yellow color compound. Okay, so this will have a formula of COCl3.5NH3. And this will have a formula of COCl3.6NH3. All of you got this? Yes or no? Please tell me. Are you guys with me till here?
Yes, sir.
With the experimental results. Okay. Now that means, see, can you see that why it is very interesting? Because whatever chemistry you have learned till now, if you are going to react to different molecules, it is going to give you only one product. No matter what is the ratio, आप एक को limiting reagent कर देते थे. Do you guys remember this limiting reagent from 11th standard? Yes or no? Nawal and Rifat?
Yes, sir.
है ना? But यहाँ पे देखिए क्या हो रहा है. यहाँ पे if you are mixing 4 moles of ammonia, you are getting two different colors. Sometimes you get green, sometimes you get violet. When you are mixing COCl3 and 5 moles of ammonia, then you are getting what color? Then you are getting purple color. and when you are mixing 6 moles of ammonia, you are getting yellow color. So obviously it was very interesting. And Werner also thought that, okay, fine, wait a second. If we have metal chloride and we have ammonia, then obviously there will be some ions formed, and what we can say, there will be some ions formed when I add water to it. Okay, when I add water to it. Now, if you remember, if you are going to react any chloride, okay, if you have metal chloride, if you are going to react this with Ag, it is going to give you AgCl. What it is going to give you? It is going to give you AgCl. Or if you have metal chloride and you add AgNO3, then it is going to give you AgCl. So he then did precipitation studies. He did precipitation studies. With the first one, coming back here, with both of these green and violet molecules, if he added AgNO3, he got 1 mole of AgCl. When he added AgNO3 in the 5 moles of ammonia one, he added AgNO3, he got 2 moles of AgCl. And from here, he got 3 moles of AgCl. Okay, so these are some of the experiment that he did. These are some of the experiment he did, and these are the results of that experiment. Now, what he said that, okay, fine, when I'm getting 1 AgCl, 2 AgCl, and 3 AgCl, that means 1 chlorine in this molecule is what? It is independent. 1 chlorine is independent, and when I am going to add water to it, that chlorine will get ionized. Here, how many independent chlorines do we have? Tell me. When we have 5NH3, how many independent chlorines is there? Tell me, guys. If I'm getting 2 AgCl, then how many independent chlorine will be there?
1.
Okay. Yes, Nawal. Yes, Rifat. Nawal, tell me. When we had 1 AgCl, he concluded that 1 chlorine will be independent. Now, when we are getting 2 AgCl, then how many chlorine will be independent? Tell me.
2.
2. And when he is getting 3 AgCl, then how many is going to be independent?
3.
3, right? So from here, you are going to get 1 chlorine, 2 chlorines, and 3 chlorines. That means he said that, okay, fine. Then I can say the formula of this compound should be, for the first one, CO, Cl2, and NH3 whole 4. This is one entity, and chlorine is another entity. For the second one, the formula will be CO, and how many chlorines? Tell me. Cl3 था, Cl3 से कितने क्लोरीन हटा दें? बताइए. Cl3 से कितने क्लोरीन हटा दें? 2. कितना बचेगा? Only 1.
1.
Correct. And
Yes,
how
sir.
many NH3? 5 NH3. And outside you are going to have Cl2. When we have 6 ammonia, then you are not going to have any chloride in there. You are going to have 6 ammonia and Cl3. Is this clear? Yes or no? Please tell me.
Yes, sir.
ठीक है. अब यहाँ पे देखिए. What is common here? Cobalt is there, and it is surrounded by 2 chlorines and 4 ammonia. 1 chlorine and 5 ammonia. And or else we are going to have this. This is going to be 6. Or it is going to be 6 ammonia. Okay, I wrote it mistakenly. This will be NH3 like this and whole 6, because we are having 6 ammonia. So one thing that is constant that you can see here is all the cobalt is always surrounded by 6, ions or molecules. दिख रहा है आप लोग को? Yes or no? 2 plus 4 6, 1 plus 5 6, and here we have only ammonia, which is also 6. Yes or no? Please tell me.
Yes, sir.
ठीक है. Next thing that you can see here is This cobalt, it will have +2 valency. This cobalt will also have +2 valency because it is coming from what? +2 or +3. Just a second. No, it is going to have +3 valency. Sorry. Because it is coming from COCl3, right? This cobalt is coming from where? क्या हो जाता है कभी-कभी? This cobalt is coming from COCl3. That is right. Its valency will be what? All of these will be having +3 valency. Okay, +3, and +3. Because these are originating from COCl whole thrice. Then he said that there are two different valencies. He said that there is primary valency and which is equal to the oxidation number. Next, we have the secondary valency. That is going to be what? These are going to be the ions that is surrounding the metal atom. Okay, secondary valency क्या होता है आपका? It is the coordination number. It is the coordination number. So these are the things he concluded from his experiments and results. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now write postulates of Werner's coordination theory. First of all, he said in coordination compounds, metal atom exhibit two types of valencies. Primary valency and secondary valency. Okay. Primary valency is the oxidation state or oxidation number of metal. Secondary valency क्या है आपका? Secondary valency is the coordination number. Right, next. Primary valency is ionizable. That means देखिए जो क्लोरीन से आपके पास वहां पे +3 मिल रहा था, that is going to be ionizable. Okay, it is going to get converted into ions. Primary valency is ionizable, but secondary valency is non-ionizable. The third point. Metal tends to satisfy both primary and secondary valency. Primary valency is satisfied by negative ions, whereas secondary valency is satisfied by either negative ions or by neutral molecules. Done, yes or no? Please tell me. Last point लिखें यहाँ पे. The secondary valency, rather valencies, are always directed towards fixed position in space, and it leads to definite geometry. Done, guys? Yes or no? Please tell me.
Yes. Yes, sir.
Okay. Now write a question. Just a second. ठीक है. Please see this question. अभी लिखिएगा मत, ठीक है? Don't write this. कर लीजिए, उसके बाद लिखिएगा. Please tell me. On the basis of the following observation made in aqueous solution, write the formula and assign secondary valency to metals in following compounds. ठीक है? First of all, you will tell me moles of AgCl precipitated when 1 mole of per mole of compound with axis AgNO3. So how many moles of AgCl are we getting in the first case? Tell me. Only one, right? So in this case, how many independent chlorine is there? Tell me. In the first one, how many independent chlorine is there? How many independent chlorine is there? In the first case, tell me. Arey, we did this na, guys. Nawal and Rifat. 1. ठीक है. आप एक को हटा दीजिएगा. And how are you going to write the formula of compound? Tell me. Cobalt. And then how many chlorines?
2.
And then how many NH3?
4.
Very good. Now you have to tell me what is the secondary valency. Na? So secondary valency क्या होता है? Coordination number. So you add just 4 plus 2 is equal to, tell me how much?
6.
Okay. Second में बताइए आपके पास. How many independent chlorine is there? How many independent chlorine is there? How many? हाँ. अरे क्या हो गया? How many independent chlorine, Nawal and Rifat in the second case?
2.
Yes, Nawal. Nawal, tell me how many?
There's 2.
2. Rifat, what do you think?
2.
Rifat, हाँ 2 ना. ठीक है, तो फॉर्मूला क्या हो जाएगा बताइए इसका. PD. Tell me, Nawal and
Cl.
Rifat. Cl कहाँ से आएगा? दोनों Cl तो निकल गया ना बाहर. Can you see that? Yes or no? Please tell me.
Yes, sir. Yes.
है ना? तो बताइए PD के बाद.
NH3.
How many NH3? How many NH3? ओहो, कितना लिखा हुआ है यहाँ पे? All the NH3s are there ना. NH3 कहीं नहीं जा रहा, तो 4 हो जाएगा. Coordination number is going to be 4. Okay, can I move to the next one? Don't write,
Yes,
please
sir.
listen. ठीक है, अब बताइए. In the next case, how many independent chlorine do we have in the third case?
2.
2. So what will be the formula? Nickel.
H2 also.
So how many coordination? What is the coordination number?
6.
Very good. अच्छा, यहाँ पे आपके पास बताइए क्या हो जाएगा? The next case. How many chlorines are independent in the next case?
4.
4. कहाँ 4 है? यहाँ से
No.
देख के बताते हैं ना. 0 ना. Who said 4? Nawal or Rifat, who said 4?
It was me, Nawal.
Nawal, see. First में how many independent chlorines? 1. Second में how many independent chlorines? 2. Third में 2. Fourth में 0. Fifth में 0. Got it?
Okay, sir. Yes, sir.
ठीक है, समझ में आ रहा है ना अब?
Yes, sir.
Now you tell me. What will be the formula now? PT के साथ हम new. What do we have? What are
HCl.
No, HCl is dot HCl, right? Dot 2 HCl. Okay. And we have chlorine, right? So first of all, tell me PT. And then how many chlorines? How many chlorines?
Four.
Yeah, correct. Very good. And then how many HCl? How many HCl? 2 HCl. तो अब बताइए कोऑर्डिनेशन नंबर कितना हो जाएगा इसका?
6.
In the next case, PT, how many chlorines?
2.
2. And how many NH3?
2.
Yeah. What will be the coordination number?
4.
Yeah, that's it. Okay. Check. So that's it for today. We did Werner's theory, and then we are going to look at one more thing. Tomorrow you are not going to have class. Just a second. Tomorrow you are not going to have a class. Okay.
Yes.
I'm not yet sure what to do. I mean, I'm thinking maybe we can have test. What do you think?